Hello and welcome to today's session on private networks. I'm Hema Kadia from TeckNexus, and I would like to welcome my co-host Mika Skarp and our guest today, Eric, who is a CEO of Yberg and he's also a professor at Yonsei University. Welcome, Mika. Welcome, Eric.
Nice
Thank
to
you,
be
and nice
here
to meet
again.
you.
Eric, before we start, would you mind giving a brief introduction about yourself and about Yberg and your role at Yonsei University?
Okay, my name is in Korean Seong-Lyun Kim, and Kim is my family name, but everybody call me Kim so far. But I have a Christian name, Eric, as am I introduced. By the way, I've been a professor more than I guess 25 years or something. I've been at math, but it's more than 25 years something. Mostly in electrical engineering, radio communication systems. And then I've been working with ever since 2G, 3G, now with a 6G. And we have a good collaboration with a Finnish company called Cumucore ever since our collaboration with the European 5 project with Korea. And then together with them, collaboration will be extended to launching a new startup company here in Seoul, Korea. Actually, they officially last year. We have just started our activity, and that is a brief introduction of myself. Thank you.
Thank you, Eric. Mika, you want to start the conversation or do you want me to lead?
Please take a lead. I just want to give our audience a little bit of a warning. So we are on 3 different continents physically, so there might be a little bit of a delay in our discussion. So try to bear with us. But Hema, please, shoot the first.
Absolutely. Thank you, Mika. Eric, let's start with the big picture. How would you describe the current status of 5G market in South Korea? What are some of the lessons that we have learned? And as we move on to 6G, how do you see that progressing in the Republic of Korea?
Thank you for your question. If I remember, the Korea, Republic Korea or South Korea started its first 5G commercial service April 2019, about 6 years ago. And this is believed to be the first 5G commercial service in the world, and followed by US. And if you know the populations of Korea, which is South Korea, which is 51 million, and we have like 69 mobile subscriber, which of course is larger than the population. And then out of this 69 subscribers, we have a 36 million 5G subscribers. So far more than 60% of mobile subscribers are from 5G. That is kind of successful kind of spreading of 5G. And I think there is 90% of 5G base station coverage in South Korea. Of course, LTE, 4G is 100%. And what does this kind of spreading success factor could be? I think actually this is mostly primary factor was government support, like policy making and deregulations, and also ecosystems like mobile vendors like Samsung Electronics, and network vendors, Samsung Networks Division, and some other global vendors. That is a very positive side. And after kind of deployment of this 5G, 6 years have been passed. And if you meet people on streets, how do you feel like 5G in general? And they think, I mean, they didn't find that much difference between 4G LTE, and one difference might be maybe they pay a little bit more to subscription to the 5G, and they don't see that much difference from 4G between 4G LTE and 5G. Yeah, that is, I think this is a very typical answer, perhaps in the other generations as well. I have my kind of, you see this one?
Yes.
This
That's
is
cool.
this is Nokia, very popular bestseller 3G phones, which is working now as well. This is 3G phone. And then I mean, people without this 3G phone, if I ask them like how do you like 3G? And they said actually it was very good and very good service. They remember like that. But if I give them this phone to them and use it, and very inconvenient to use it, and we don't imagine how we were using the 3G phone like in a 10 years ago or more than 10 years ago. That means if they replace their phones with the LTE, then perhaps they will feel a little bit inconvenience because download speed of 5G in South Korea is now reaching 1 giga bps, which is unbeatable for the LTE. But on the other hand, when we start with the 5G, many of the operator kind of think of kind of vertical applications like smart cars or smart factory. That is, to be honest, still under struggle mode. I think I can stop at this moment, and then if you have
Yeah.
questions, I can continue.
Yeah, may I have a follow-up question, because that, the history reminds me about that the 5G introduction, so that there was this little bit of a race between the China and Korea. So China said that we will have the 5G in the Beijing Olympics, and then the Koreans said that we will have the 5G in the Winter Olympics. And then it was obviously NSA non-standalone implementation at the time. But how is it nowadays in South Korea? Is it still on the NSA, or do you have a kind of SA networks for the consumers?
Yeah, very good question, Mika. I want also point out this perspective from my side. Answering to NSA or SA, we have very few SA kind of base station or 5G core. And I would say actually the almost every coverage is supported by non-standalone, which means operators are reluctant to invest further on to SA. So this is a little bit different from our original expectation like in 6 years ago. That is one side. And then if you remember this millimeter wave, like 28 millimeter gigahertz band, that was very much demonstrated at Pyeongchang Olympics. I think it was 2018 in Seoul to demonstrate feasibility of this technique. And lots of collaboration between Europe and Seoul and I guess China and USA collaborated on kind of spreading out this millimeter wave services. Now in Korea, we think actually that we are the originator, one of the originator of this millimeter wave. When an interesting situation is that actually we don't have any millimeter wave service provider in Korea. That is something that we missed at the policymaking in the beginning. So the other side, like let's say actually the other side of the widespread of 5G, there are missing 2 points. One is standalone type of systems supporting like 5G core and supporting network slicing, some nice features of something that is missing at the moment. And then next, another thing is, as I said, millimeter wave, which was very much actually the originally, kind of approached by audience and somewhere. And from that side, people on the street are a little bit kind of disappointed at the point originally the operator promised with the 5G services.
Yeah, I think from those service sides, so that if you have an NSA, so it's in my mind it's a kind of LTE plus or LTE advanced that you have, and of course it's a faster download, and then from the consumer perspective it's not it's good, but it's not revolutionary. But hey, if we jump to the private network side, what is your experience? What is your opinion? Why the factories in South Korea are looking at these 5G networks?
Well, now if moving to the 5G network, there is no reason to use NSA. It's very straightforward to use standalone system infrastructure. So that's one side. And in Korea, we have private 5G band, frequency band spectrum released from the government, which is 4.7 gigahertz spectrum band. The bandwidth is about 100 megahertz. And that was also the released from the government, such as kind of top-down approach. I mean, they investigated use cases in other countries, like in Germany and in Japan. And then they would like to use this kind of private 5G systems in Korea. We call this as a EUM 5G in a Korean name. And then people started to use these systems in-house or factories and some other kind of auditorium, whatever it is. And then why we go to the factory first? I mean, if you go to the factory, whether it's a modern or any other level, it's a kind of robot and manufacturing machines that are somewhere connected to their servers for controlling. And then these controlling systems, as in Mika known, actually the mostly based on Ethernet, kind of wireline or Wi-Fi. And that kind of bandwidth is now is limited and becomes a bottleneck because nowadays current machines and vision cameras generate much larger data than before. So that Wi-Fi may not be the good solution, even if it's affordable and cheap to use it, price level. Now, the other thing is devices are much more mobile these days. I mean, you could change layout in the factory somehow depending on your situation. If it's a wire line, then difficult to change its layout, very expensive. So with these two factors, factory is right place to use private 5G. And of course, our competitor is Wi-Fi systems. Wi-Fi is also evolving and their standard and services are evolving as well. Okay, I mean, I can continue my answers if you have further questions then.
Absolutely. I'll just continue on the same question, Eric. I wanted to understand when the enterprises are evaluating their journey on private networks, what are some of the key considerations depending upon the size of the company, depending upon the number of sites, because that would really need to focus on the scalability in the future. So, what are some of the key considerations and how are they approaching it from a
I mean,
solution perspective?
your viewpoint is from factory owner's perspective or operator's perspective. I mean, when you define success,
From the enterprise perspective. I mean,
enter.
yeah, from the enterprises who are deploying private networks.
Okay. From my experience from Korea, the first criteria was price.
Mhm.
Because when you approach them, they ask questions, very fundamental question. Is this better than Wi-Fi? We said yes. And then how much expensive this one compared to the Wi-Fi? And if the price is a bit expensive, then their one expectation, they will stop it. So first kind of a barrier or a success factor should be the affordable price to them. And to be honest, I think, I mean, this is a big barrier for 5G services into manufacturing because infrastructure was expensive because they have lots of investment on developing 5G systems. So this is just the initial phase. So the price is going to be a little bit higher than their one expectation from enterprise perspective. That is one point. And of course, I mean, second point is like this. I mean, if you replace this by private 5G, then can you guarantee like in a reliability or security? And from cost-wise, I mean, if we operate long term, this will replace some of our kind of, let's say this is a sad story, but human workers by using some applications and then reduce costs like their operating cost. So even if it's the infrastructure is expensive, if it is actually the benefit is greater than their operating OpEx, they are willing to buy this. But anyway, the primary factor is how much the price. And then beside this, one thing I can figure out is complexity of the system. I mean, as you know, Mika, in you, this mobile operation requires lots of expertise. I mean, we are very much interested in one side, but this is a complex of different expertise like mobile terminal operations and like the base station something. And then for those enterprises, in particular SME, they don't have such expertise. So once they have a private 5G network, and this is a bit different from Wi-Fi network. If you have a Wi-Fi network, then you turn on and turn off. That's it. But on the other hand, in a private 5G network requires fine optimizations or fine tuning of those parameters, which requires some expertise. So the second question from the enterprise is actually we are not experts on these 5G systems. So can we get some help from your side? And can we be independent of your services? I mean, this must be kind of autonomous type of infrastructure. They can run, I mean, they can run for themselves. So that is their secondary concerns. So these two kind of barrier should be overcome. First one is price. Second one is technical complexity for them.
Yeah, for the audience that is a kind of a little bit older, or let's say that well, more experienced, they remember that when the Wi-Fi was introduced, it wasn't that easy. It was a kind of a struggle to get the access point working at your home. So I think it gives us, or it kind of shows us that the 5G it needs to kind of evolve. It needs to be easier for sure. But I'm kind of optimistic about it, that we are gradually we are getting there, that it will be easier to use, and kind of and when there are more and more people who are exposed to the 5G technology, so they can actually start working, or they have a they start working on it. And that kind of leads us to the next question on our path, that when we have the 5G network in the factory, so then it needs to be integrated either with an IT or OT networks or OT systems. So how do you see that, and how do you see the future? As if we look a little bit to the 6G side, that the auto kind of integrating the cellular technology on the automation networks.
That is from use case perspective. If you don't mind, if I share my screen with some of our experiments, I have three video clips that will explain your
Sure. Yeah, go ahead.
thinking. So let me share my screen. Okay. And then there is some video files here. Okay.
Can you make it a full screen so that?
Okay, so let me start with this one first. Okay. This is the first screen. Can you see this?
Yes.
This is actually actual implementation in collaboration with Mika's Cumucore and my one company, Yberg. And then there is a 5G terminal modem UE attached, and this moving robot. And this is a AMR or HV, whatever it's called. And then it is connected by a kind of a small cell on the ceiling. So it takes actually elevator lift for himself, and then deliver some packages to one of those actually staff members here. This is kind of pharmacy company in South Korea. And this is a typical 5G vertical scenario, maybe when we started 6 years ago. Let me see the. So why do you use kind of private 5G better than Wi-Fi? I mean, this is a coverage issue as well, and interference issues. And then when this enters into the lift elevator, then connection must be a little bit disconnected. But cellular strength is radio strength is slightly higher, so it is not that much disconnected. So there is a vivid merit of using kind of private 5G in kind of factories. And this is, let's say, the first generations of factory services using wireless connection. And let me move on to my second example. Okay, let's move on to this one. This perhaps Mika has seen this one already, but this is for explanations. This is a robot. This is a robot. It has a vision camera here, and then the vision camera monitors situation there. This is a typical kind of a coffee makers and then coffee pots, and coffee powders are here, and this is a coffee dripper. And this mimics the human barista when they drip coffees. I mean, if you really are like kind of serious coffee drinker every morning, then you probably have a very serious coffee making kind of a process like this. And then what they was actually this robot monitors the situation here in the bottom, and then if something happens, then it's powering water some positions and stop position, and then. So this is just kind of digital twin systems of human barista, which requires massive data consumption from the uplink perspective. This is a little bit different from my previous example. And because this vision camera takes lots of data consumption to upload data to the servers. And servers, there's a machine learning algorithms running. And then take connections and like whether powering the water or stop it or something. This is kind of current generations of utilizations of a private 5G network or 6G network in factory, because we need lots of data consumption in the uplink. Then the question is what, yes?
This is the most expensive, coffee maker
Coffee
in the
making, yeah,
world,
right.
I would say.
Yes.
Yeah.
Like a typical passenger car price of coffee making or something. And then if I move to the next moving pictures, which is our current experiment, perhaps this one. This one is the same barista, but understands our kind of menu ordering. For example, if I ask this robot, like, I want this kind of caramel macchiato, or some other menu which is very complex. I mean, it's a verbal language, and then understand my one kind of order, and then this machine prepare materials and make decisions on the sequence of their actions. This is large language model or small language model based robot, like so this is a physical AI that combines large language model into their actions. So I ordered really bit complex kind of menus like a caramel macchiato, whatever, and the robot decides which material I have to prepare and which water sequence that I have to kind of mix to the customers. And this is actually the combination between edge and computation using this small language model, which has a kind of a 1 point some billion parameters. And then when the task is really bit complicated, it should be connected to the cloud, which has a large number of like large language model, like which has like 30 billion something parameters. So we think that actually this must be the next generation smart factory models that combine robots and AI ML. So for that case, we need some computing power at the edge, but in between, there should be a very fast connection between edge and cloud, small language model to the large language model. For that, still the uplink will be very much congested. And then I think even 5G or 6G will support these services, I think. So that's from my side at the moment, yes.
Thank you. Thank you, Eric, for that demo. Much appreciated.
Thank you.
Eric, coming back on the point that you mentioned about the complexity that is one of the challenge that the enterprises
Mm,
face. So
mm.
who are they depending upon from the ecosystem perspective? Are they depending upon operators to fill that role? Are they depending upon the vendors like Samsung to fill that role? Or it's a combination? Like how are the enterprises looking at the
Mm.
holistic solution and who are they working with as a primary partner?
I think, I mean, this is a very good question. And also, Mika, you might have a different opinion, but my one opinion is that this is a role by academia or startups. Because when we approach small companies like SME for installations of smart factory kind of things, they do not have any expertise on that. And for us as well, we are very limited human resources. So we sometimes get some help from base station company or even further. And we have lots of parameters for fine tuning. But after all, I think we need automate. We need to have a process kind of automating, optimizing those parameters using, I guess, AI, ML, machine learning. I mean, if you have an infrastructure and then lots of parameters, and then these parameters are optimized according to the environment, kind of a small SME factory situation. And this is automatically adjusted to according to the experience or data before, which I mean actually AI ML. And that will be perfect. And this may be the role of academia or startup companies. So if there isn't one company like in a Cumucore and Yberg who has such kind of a functionality, that will be very kind of welcomed by SME companies because it's a kind of headaching or kind of painful process to fine tuning of the all parameters. I mean, when I ask, when they ask me like Wi-Fi or probably 5G, which one is better? I mean, I would say actually because private 5G is the most advanced radio technology so far. So why don't you use it? But on the other hand, I would say actually this is the most complex kind of radio system so far. I mean, so that means there must be some automated process, and this must be, I think, is a sector by startups or third parties, and that will be a very good bridge between kind of a system and SME companies, and even therefore operations. And next generation system, I mean, infrastructure was originally very huge. I mean, if you remember the first generation's wireless systems, huge tower or something, and just one very rich person can use it. But now we have a private 5G. I mean, five station at home should be very affordable price and easy to understand. And so in between, we need to have kind of such automated process supported by, I think it's academia or a startup something. Okay. That's
Yeah,
from my side.
I think that the 5G, you know, as an air interface or you know as kind of a as service, I think nobody is kind of saying that it's worse than Wi-Fi. It's definitely, you know, if you look at the systems, it's the by you know for sure it's better, especially you know in these kind of industrial environments and where you have an outdoor kind of coverage needs. And now the pricing needs it's there. I think you know that the pricing is you know on the same ballpark with the Wi-Fi. So I think that's also going away. But there is still this problem of the complexity. So that's something also what we hear, you know, all over the world that you know this is great system when you get it working, but it's a little bit you know painful to get working in the first place, and especially you know integration with an existing infrastructure. So there is a lot of work to be done, and I think yeah it's a startups and but then it's also the kind of a regular system integrators that you know that there is IT departments or you know outsourced guys who will then play with it. And I believe that there are quite a lot of 5G companies in the world. So the competition is tough, and then it means that also I hope that the evolution cycle is very fast. You know, we can get forward very quickly. I think that's the thing. But, I think we have now used some of the time, but I would like to kind of because I know that you work a lot with the future stuff, so would like to take the opportunity to ask about the if we look at it 5 years ahead. So what do you see? Where is this private network business going to?
Okay, so once again, let me share my screen with one of my slides. Can you see my screen?
Yes.
Yes, we can.
This is typical kind of 5G or even 6G systems. And if you look at this leftmost photo, this is a typical baseband unit in G Node B or base station, or there is an open LAN system. This is one part is a typical integrated baseband unit, CUDU combined, whereas the upper part, we have a CUDU separated open RAN system. This is hardware-based system. And now in the middle, you have Dell, which is a computer. And then a computer means it runs software. That means the base station going to be from hardware to the software. This is not the future kind of trend, but which is currently ongoing, so-called the virtual RAN, called the vRAN. So with this vRAN kind of things, I mean, everything's going to be softwareized, which means, I mean, now the base station building or base station manipulation will be not only for big vendors like in Ericsson or Nokia or other big companies. Perhaps some schools or some startups in their one gearhouse, then they could have their one base station software, of course, compatible to the standard, and deliver it to the user user task-oriented services. That will be the future trend of private 5G or 6G network. And that is one side. That means more small size, more compact, more virtualized private 5G network. And then second trend is once this becomes a software, then we can replace some of our functions, typical functions by futuristic algorithms. That means if I introduce our project with European partners called acronym is 6G Arrow. This is a Mika typical European project. And many of the European projects has the name of so-called AI native something, AI RAN or Open RAN or vRAN or something. This is one example. And what is interesting to us is we gonna redesign core or CUDU according to the next generation use cases. So that means current CUDU architecture, core architecture may not be optimal for the next generation. I mean, which is at the moment very complicated to understand. So my point of view is make it more comprehensive, easy to understand, and easy to deploy. So this is one of our example that we are planning to do that. Redesign next generation's CUDU 5G core to adapt to the next generation kind of machine learning services like large language model based previous my one example. So that is futuristic kind of things that I am doing. So my final comment is I'm living one day once in 5G systems, once in 6G systems. I mean, I'm living every day in two different time zones. I mean, I'm living time zones in the 5 years ago, which is 5G, and I'm living in a time zone in 5 years from now on, like in a 6G. So in between, I'm very much thinking about what's going to be the next generation system should be, given that current 5G system has such complexity and price levels or something. That's from my side.
Thank you, Eric. Much appreciated. Thank you for sharing insights on 5G, on private 5G, specifically for the manufacturing sector and all the demos. I really appreciate your time.
Thank you. Thank you, Mika.
Thank you. Thank you. It's always a pleasure to meet you and discuss about this great technology.
Bye. Thank you.